Alright, in this video we're going over quadratic systems part 2. LEQ for this lesson is how do I solve and graph systems of quadratic equations. Alright, solving a quadratic system of equations. Now, to solve a quadratic system, you do it, one way to do it is by substitution, just like we did when we had a linear and a quadratic system. So what we can do is, since we know that both of these equations equal y, we can simply set them equal to each other and solve them that way. So x squared plus 7x plus 12 equals negative x squared minus x plus 12. Now, we need to get everything over on one side. Since the negative x is here, I'm going to move everything over this way. So add x squared, add x minus 12, so all this cancels. Add x squared, why did I do that? I'm thinking ahead of myself here. Add x squared, add x, and minus 12. So that cancels, so we're going to have 2x squared plus 8x equals 0. And now you simply solve for the x. Here it looks like we can pull out a 2x, so this gives us x plus 4 equals 0. So 2x equals 0, and x plus 4 equals 0. Divide both sides by 2, and you get x equals 0. Subtract the 4, subtract the 4, so x equals negative 4. Alright, so we got x equals 0 or negative 4. Now, let's pick which one of these is a simpler equation, plug these back into it to find our corresponding y values. Alright, we need to get our corresponding y values. So I'm going to pick the second equation here, the y equals x squared plus 7x plus 12. Plug in the 0, basically this term's gone and this term's gone. So when you plug in the 0, all you're left with is the 12. Alright, so let's plug in the negative 4 now. Y equals negative 4 squared plus 7 times negative 4 plus 12. Well, negative 4 squared is 16. And then this is minus 28. And then this is plus 12. Well, 16 and 12 equals 28. And then you have the minus 28. So y equals 0. So at negative 4, y equals 0. So our two solution points for this system of quadratic equations, for this quadratic system of equations, our two solution points are 0, 12, and negative 4, 0. So we solve this just like we did in the last video. You want to get everything on one side so you can have this equal to 0. Alright, because we're doing substitution, so since both of these equal y, you can basically set them equal to each other and solve for x. So we set them equal, move everything over, so it equals 0. So 2x squared plus 8x equals 0. You can factor out a 2x here to get 2x, and then in parentheses x plus 4 equals 0. Set each factor individually equal to 0 and solve for x. And after we did that, we just simply came back up here, picked the equation that we thought was the simplest, plug in each x value to get its corresponding y value. Alright? So solving by substitution, that's all. That is all there is to it. Alright? Now, you can also solve these things by graphing. So let's take this same, let me get a graph here. Let's take this same equation that we just solved using substitution, but now instead of using substitution, we are going to use graphing to solve it. Alright. So what we need to do is we need to go ahead and what I would do is I would find the vertex of each one. So remember, your vertex is negative b over 2a. So let's do this top equation. We're going to have negative b is negative 1 over 2 times a. Well, a is negative 1, so this is going to be negative 2. So we're going to have negative 1/2. Now, you plug in the negative 1/2 to get the other vertex. So we're going to have y equals, I'm sorry, not to get the other vertex, to get the y coordinate of your vertex. So we're going to have negative 1/2 squared minus negative 1/2 plus 12. So that's just a simple punch it into your calculator. And you should get 12.25. So the vertex of this equation is negative 1/2 and 12.25, which is 12 1/4. I'm just going to leave it like that. Now find the vertex of this one. We know it's negative b over 2a, so we're going to have negative, and then it's 7 divided by 2a, which is 2. So we have negative 7/2, which negative 7/2 is negative 3.5. Okay. This into your calculator, and you're going to get that the y value of your vertex is simply negative 0.25. All right, now let's go ahead and graph this. So let's graph our vertex for the first one. Now I'm going to make these go by ones. And I'm going to make the values on my y-axis go by 2's, just because it'll make it easier for me to graph it. All right. So negative 1/2 and then 12.25, so 12 and go a little bit above it. Now we know that C is the y-intercept, so 12 is our y-intercept. We know that's going to mirror over here. All right. So let's go ahead and draw in our first parabola. That's terrible. All right, and then draw in your second parabola. So negative 3.5 and negative 0.25, so it's going to be down here. And we know our y-intercept again is going to be 12. And we know that's going to mirror over our axis of symmetry, which is also runs through our vertex. So there's our poorly drawn graph. But as you can see, they do in fact cross at 12, 0. I'm sorry, I wrote that backwards. 0, 12. What am I doing? And you can see they cross right about there, which would be negative 4, 0. And if you confirm that with the previous page, those are the same two solution points. Okay? Those are the same two solution points if you confirm it with the previous page. Alright? So that's how you solve them by graphing. You simply graph them either by hand like we just did, or you can graph them on your calculator and use the intersect feature. But all you do to find the solutions is look to see where both graphs cross. Now, if you draw these by hand, you have to be very careful to make sure you draw them properly. Like here, I knew that they crossed at 0, 12, and negative 4, 0, so I made sure they crossed there. But if you're drawing these by hand the first time, you need to make sure that you just don't use 2 points. I would make a table of values and graph many points. I would not just graph 2 like I did. I would graph many. So that way you can verify exactly where they cross. Now you can always test them. All right? 0, 12 and negative 4, 0 should solve both equations. So you can always test them. If you're like, okay, it looks like it crosses here, just plug your point into both equations and it has to solve both. If it doesn't solve both, double check your graph and make sure you drew it correctly and to scale. All right? So what I want you to do is take each one of these and solve them. You can either use substitution or graphing. So So pause the video and solve them. For this one is I'm just going to solve using substitution. So I'm going to set them equal to each other. And I'm going to solve them this way. So let's add the x squared, subtract the 5, add the x squared, subtract the 5. So that cancels. So we have 2x squared minus 4x equals 0. So it looks like we can factor out a 2x from both of these, and we're left with x minus 2 equals 0. So 2x equals 0. So x, of course, equals 0. And x minus 2 equals 0. So add 2, add 2. So x equals 0 and 2. Now, pick whichever one you think is easiest and find the corresponding y values. Obviously, I think this one is going to be easiest. So y equals negative x squared plus 5. So when you plug in the 0, this is basically gone, and you just have the 5. So 0, comma 5 is one of them. Now plug in the 2, so we're going to have y equals negative 2 squared plus 5. So this is y equals negative 4 plus 5. So y equals 1. So our second point is 2, comma 1. So for 3a, those are the two solution points you should have gotten. Whether you graphed them or solved them by substitution, it doesn't matter. You should have still got 0, 5, and 2, 1. All right. Now for letter B, I'm going to solve it by graphing, obviously, because I put a graph out here. So the first thing I'm going to do is I'm going to get the vertex of each one of these. All right. So let's get the vertex of this guy. Well, we know it's negative b over 2a. So negative, and then b is negative 4 over 2a. Well, a is 1, so this is just 2. Well, that's plus and plus, so this is 2. So our x value is 2. Now we just got to plug it in and find our y value. All right, so when you plug it in, you're going to get 2 squared. What can I write this? I'll do it here. You're going to get y equals 2 squared minus 4 times 2 plus 5. So you're going to get 4 minus 8 plus 5. You're going to get negative 4 plus 5, which is 1. So 2, comma 1. So 1, 2, 1. There's our vertex. Now for this one, our y-intercept is, remember, it's just c, so our y-intercept is 5. 1, 2, 3, 4, 5. And remember that mirrors over the axis of symmetry. And since, so let's draw this in. That was kind of bad. That was supposed to be an arrow on the end of that. All right, let's now with this one. If you remember your transformation stuff, this is facing down, and this makes it shift down 5. So this would be 1, 2, 3, 4, 5, and it would open downward. So it would look like this. All right, because remember, this negative turns the parabola upside down, and then this negative 5 moves it straight down 5 units. So here's our two graphs. Are they ever going to cross? No, because this one's pointing up, this one's pointing down. There's no hope of these things ever touching. So the answer to B is no solution. Okay? This problem has no solve. All right? So hopefully you got that for both of these. For the first one, again, you should have got 0, 5, and 2, 1. And for letter B, regardless if you graphed it or solved by substitution, you should have gotten no solution either way. All right, you should have gotten no solution either way. All right, let's move on. Solving a quadratic system of inequalities. Solving a quadratic system of inequalities. All right. So the first thing we need to do, obviously, is we need to graph these things. So to graph them, we need to find the vertex of each. So let's go ahead and do that for this first one. Vertex. Alright, so we know it's negative b over 2a. So it's going to be negative, and b is negative 9 over 2 times negative 1, which is negative 2. We have an odd number of negatives, so this stays as negative 9 over 2, which is negative 4.5. Right, now, again, to get your y value, you simply plug the negative 4.5 into this equation like we've been doing, and when you do that, you get 18.25. Alright, you get 18.25. So again, I'm going to go by 2's on all my axes. 7, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Alright, so let's plot our vertex. Negative 4.5, so negative 4, a little bit past it, 0.5, and then up to 18.25. So about right there. And then of course we know here our y-intercept is negative 2, so it's going to cross right there. And of course we can mirror that over the axes. So right there. So our first graph, and it's dashed because there's no equal to bar. So our first graph is going to look like this. Alright? And since it's less than, it's going to be everything shaded below it. So everything inside here is going to be shaded because it's everything shaded below it. Now, if we look here, this is x squared minus 2. Again, if you remember your transformations, this is just simply your regular x squared graph moved down 2. So our vertex is going to be here. Alright, and if we go over 2, okay, over 2, we can go up 2, and over and up. So this is what our next one is going to look like. So, and then this one is everything shaded above it. Alright, so the answer to this solution is going to be everything in here. Alright, everything where these two graphs overlap. Alright, that is your solution set. So this one actually has many solution sets. Okay, because they overlap, not one single number, or not just one single number, solves both of these inequalities. Every number in that shaded area will solve both of those inequalities, so that is the solution to that system of inequalities. Alright? So, what do? All you do is you graph your two inequalities, put in your shading, and where your two shadings overlap. Where your two shadings overlap is where is the solution set to your system of inequalities. Alright? Now, I want you to try this one. What is the solution to this system of inequalities? And then I want you to think about it. How many solutions can a system of inequalities have? I'll give you a hint for that. There's 3 answers. Alright? So pause the video and figure this out. Alright, let's graph these. So for this one, we know this one's pretty simple. It's simply x squared moved up 3. So let's go up 1, 2, 3. And then of course we know it's going to go over 1, up 1, and then back 1, up 1. So this is what that's what the second one looks like. And it's greater than, so it's everything shaded above it. Let me put in some shading in here. So there's some shading. Alright, now let's graph the other one. For this one, it's going to be easier to just find the vertex. So negative b over 2a. So that's going to be negative, negative 4 over negative 2 because it's 2 times negative 1. So that's positive and positive. 4 divided by 2 is 2. And since we still have this negative out here, the x-coordinate of our vertex is going to be negative 2. Plug in the negative 2 to get your y value of your vertex. We're going to have negative 2 squared minus 4 times negative 2 plus 3. So 7 is our other vertex. Negative 2, 7. So 1, 2, 7. 1, 2, 3, 4, 5, 6, 7. And then our y-intercept for this one is 3. So 1, 2, 3. And of course that mirrors over our axis of symmetry. And since this one has a greater than bar, it's going to be solid. Alright. So let's put some shading in here. And this one is y is less than, so it would be everything shaded below it. So if we look at where the shading overlaps, it overlaps in this area right in here. And that is the solution to that system of inequalities. Alright? Where they overlap, where the shadings overlap. So if you notice, this is kind of like linear systems. You graph your lines, or you graph your equations, whether they're lines, or they could be nonlinear as well. So, but you graph your lines, put in your shading, figure out where your shading overlaps, and that's your answer. So it's very similar to this. You graph your parabolas, put in your shading, figure out where your shading overlaps. Alright? Now, letter B. How many solutions can a systems of inequality have? Well, the first answer is easy. When they overlap like this, there can be an infinite number of solutions. Alright? When they overlap like this, there can be an infinite number of solutions. Alright? Now, what happens if when you graphed your parabolas, they didn't overlap, but they just touched? Okay? If they touch, they're only going to touch at one single point. And if they only touch at one single point, that means there's only one solution. Now, you can also graph inequalities, a system of inequalities like this, and the parabolas not touch. And with the parabolas not touching, if the shading doesn't overlap, all right, like for instance, if we had a parabola up here that was shaded here, say we had another parabola down here that was shaded inside of it, the shadings would never overlap, so those would have no solutions. All right, those two would have no solutions. So how many solutions can a system of inequalities have? They can either have an infinite number of solutions, they can have one solution, or they can have no solutions. All right, because this one here has an infinite number of solutions, because I can always find you a point next to the point that you find. So they can have an infinite number of solutions. They can have one solution, which means the parabolas just touch. All right, so the shading here would be here, the shading here would be here. So they just touch right there. So that's one solution. Or you could have a parabola up here with the shading above it, have a parabola down here with the shading below it, and they would never have any hope of crossing paths. So no solutions. All right. So this has been your part 2. Feel free to watch this video as many times as you need to, but make sure when you come to class tomorrow, you're ready to work some problems. See you tomorrow.